Hey guys, Mr. Backerberg here. In this video, we're going to look at annual percentage yield. Now, as we look at doing these financial examples, and as you look at making investments in your real life, there's a lot of options available to you. There's a lot of different interest rates, and there's a lot of different methods of compounding. So it can sometimes be pretty difficult for a consumer to compare all of those different options. So for example, would it be better to invest your money in an account that earns 8.75% but gets compounded quarterly? Or would it be better to invest in an account that only gives you 8.7% but it compounds monthly? So what we're going to look at calculating is something called annual percentage yield, or APY. And annual percentage yield is the percentage rate that, if you were to compound annually, would yield the same return as the given interest rate with the given compounding period. So we're going to take a look at this example where you invest $2,000 in a credit union at 5.15% annual interest, and that gets compounded quarterly. And we want to figure out what the equivalent annual percentage yield would be. Now, as we're taking a look at this problem, we have to remember our compound interest formula. So that goes A equals your principal amount times 1 plus the interest rate over the number of compoundings raised to the power of KT. So taking the number of compoundings times the number of years. Now, here specifically, we're going to be talking about a time of 1 year. So what we're going to do is let X equal that unknown annual percentage yield. So if we were thinking about using our compound interest formula, then we would have our principal amount, which is the $2,000, times 1 plus the unknown interest rate, which we're calling X in this case, over the number of compoundings. Well, this one we're only compounding annually since it's our annual percentage yield. So the number of compoundings is just going to be 1, and that's going to be raised to the first power. Now we're comparing that to this example where we've got 5.15% and we're compounding that quarterly. So if we were to plug things into our compound interest formula looking at that, then we would have the 2,000 times 1 plus our 0.0515 over 4 raised to the power of 4. And again, the time, we're just looking at one specific year, so that t value would be 1. Now what we're looking for is where these two pieces are equal to each other. Now, before we go too far with solving this, I'm going to clean up the left-hand side a little bit. It's really not necessary to take x and divide it by 1. Dividing by 1 doesn't change anything, and it's also really not necessary to have this 1 power on the left-hand side. So really, we can think about that left-hand side as just being 2,000 times 1 plus x equals our 2,000 times 1 plus 0.0515 over 4 raised to the power of 4. Now, as we're thinking about solving this, the first thing I would do is get rid of this 2,000 on each side. So if I divide both sides by 2,000, then those values will just end up canceling out. So I get 1 plus x equals 1 plus 0.0515 over 4 raised to the 4th power. And then our goal here is to solve to try to get x alone because we're trying to find this annual percentage yield. So all I have to do is subtract that 1 over to the other side. So then we end up getting x equals 1 plus 0.0515 over 4 raised to the 4th power minus 1. And if I type all of that into my calculator, I should get the decimal 0.0525. So that's our annual percentage yield. And if we were to take that and convert that into a percent, it would be 5.25%. So what that means for us is this $2,000 investment that we had at 5.15% compounded quarterly for 1 year earns the exact same amount of interest that we would get if we took our $2,000 and invested it in an account that paid 5.25% just one time at the end of the year. Now, there is a formula for calculating annual percentage yield. And what it's going to look like, your annual percentage yield, what you have to do is take 1 plus your interest rate over the number of compoundings raised to the power of the number of compoundings, but then you're going to subtract 1 from all of that. And this formula will be helpful as we look at comparing different interest rates and different compoundings to figure out which one gives us a better annual percentage yield. So let's think about that example that I brought up earlier where we wanted to compare a couple of different interest rates and compounding amounts to figure out which one would be a better investment. So we wanted to compare getting 8.75% interest compounded quarterly, and we want to compare that to getting only 8.7% interest but compounding monthly. To compare the two, we're going to calculate each one's annual percentage yield to see which one has a higher APY. So as we're thinking about calculating the annual percentage yield for this first one, then what we said we were going to do is take 1 plus the interest rate, which would be 0.0875, over the number of compoundings, and since we're compounding this quarterly, that'd be 4, and we're going to raise that to the 4th power, but then we're supposed to subtract 1 from that. Now, if I type all of that into my calculator, then I'm going to get 0.09041. So our annual percentage yield here is going to be 9.041%. Now let's look at finding our annual percentage yield for this other example to figure out which one's better. So to calculate the annual percentage yield, again, we're going to go 1 plus the interest rate, so 0.087 over the number of compoundings. Here we're compounding monthly, but then we're supposed to raise that to the power of 12, and then I need to subtract 1 from all of that. Now if I type all of that into my calculator, I should get 0.09055. And if I convert that into a decimal, I get 9.055%. So this second one has a slightly higher annual percentage yield, making it a more attractive investment. That's going to be it for this video. Thanks for watching.